Hey guys, my name is Dominic Flux, and today I am joined by Benjamin and Lauriane, who've recently started a casting house. And so we're going to show you the behind the scenes from A to Z. We're talking about the design process, the printing, casting, the finishing, because it's extremely technical. And so we just want to give you a little sneak peek about all the work that goes into jewelry, so stay tuned. All right guys, so now this is the first step of the process. I'm here with Nathan, he's a 3D designer, and basically as you can see, he's designing the rings here in Rhino. So this is like really the first step. The client, I guess, reaches out to you.
Wait.
Yeah, they reach out to you, they say this is what I'm looking for, they recreate it in 3D, and then it goes off to the print. So it's pretty cool.
Yeah.
Yeah. Do you use any other softwares or just Rhino?
No, just Rhino.
Rhino. I know, that's the best. Matrix are lazy. They're lazy. So the first thing we touched on was the 3D design. Now, once it's made, it's basically sent to one of these printers. Do you want to explain the process?
Exactly, sure. So it's a wax printing machine, the highest quality we find on the market. It's 8 micron layers. So it goes, I prepare everything in the computer, then everything appears on that screen. I just have to press play, it's that easy.
Yeah.
And then the machine's gonna start. What it does, it builds the pieces into support wax. And then the next step is gonna be to dissolve the support wax to get the actual piece we wanna cast.
Yeah. Can we show them an example?
Yeah, sure.
Yeah.
So for example, we have that ring.
Yeah.
The ring that we're interested in, the piece we're interested in is the red piece, and the white wax is going to be dissolved to make the ring appear.
Yeah, exactly. So basically they're going to take this and they're going to put it inside one of these solutions, and it's going to dissolve that white piece, and you're going to have just the red ring at the end.
Exactly.
So, and that's what we're going to use to cast. In terms of, like, a lot of people, there's different machines on the market.
Yeah.
So there's resin, there's wax. What do you use and what do you think is better?
So there's multiple use for printers, but what I think for jewelry and high-end jewelry, the wax is always better.
Wax
There's
is better.
that little part that can be a bit tricky. It's the de-waxing. So anytime you have a cavity or things inside, it's a bit more complicated to de-wax. So some people are gonna go through resin casting. It's a bit easier in that way. But for the surface quality and the finishing quality, I always go with wax.
With
printing.
wax, okay, yeah, because I think a lot of people will also use resin printers just because they're significantly less. Like, I think the classic SolidScape is like, what, 60-some thousand?
Exactly.
Versus like a resin printer you can get for like, what, 3,
1,000.
4,
Yeah,
1,000 now?
The best on the market is going to be around 1,000 or 1,200, yeah.
Yeah.
But it's not much the printing itself, it's the
Okay.
product that it prints in. We always have that mix of resin and wax. So now at the point we're today, the resin are good enough for casting. It's just a question of surface finishing.
Surface finishing.
The
Porous. It can be more porous, I'm guessing?
Not much porous, it's just that when the burnout cycle goes with the resin, it have a tendency to leave a tiny bit of burnt residue all around the piece, and that's why you may have some marks in the finished casting.
In the finished casting, okay. And that will appear as dark spots, or it's just more labor to remove?
A bit more labor to
Yeah.
remove. You're gonna have some, looks like tiny holes, and it's actually the ashes that marked on the metal while it was injected.
Very interesting, very interesting. And how long does it take to print a ring?
One ring is usually not interesting to print only one ring
Yeah.
in those big machines because it's gonna take for sure 45 minutes.
45 minutes. Okay,
But-
that's not bad.
No, it's not that bad
Yeah.
for a wax printer, but
Okay.
I put one ring or I put 7 rings in, and besides it's gonna be 45 minutes as well.
Okay.
So it's more the height that's gonna define the time of printing. Yeah.
Okay, very interesting. And this is really cool because printers actually print at like what, 0.01 millimeters?
No, 8 microns. So
8
you
microns,
take a
okay.
micron is a millimeter divided by 1,000, and you take 8 of those. Yeah. Yeah.
Very cool.
As Benjamin said earlier, is you want to have the red ring, right? You want the finished product to be as detailed as possible with no surface porosity. So what you do is you find a solution that sometimes contains alcohol, for example, where you can dissolve the white wax without touching the red one to have a perfect casting afterwards. So that's one of the difficulties of the casting.
Yeah.
One of it.
So this is what you're seeing here. It's a different bath. I guess you guys did a lot of formulations to get the best. So
Exactly.
it's pretty cool.
So like I said, a lot of research, a lot of testing, and each of these has a specific use for a specific kind of wax.
To have the best quality of casting, we have to be very precise on our alloys, the quantity of used gold compared to the quantity of new gold or new metal in general. There's always that moment in casting where you lose all sight of what's going on inside the cylinder. That's why you have to be very precise before and very precise after. So with the preparing of the metal, the burnout and the quenching are what you can control. Once is in the oven or in the machine for the melting, you lose sight of what's going on. Okay, so all process. We always start by putting our alloy in the bottom of the crucible.
Why?
Because the alloy is going to be what oxidizes the most, and it's usually have a lower temperature than our metal, the main metal, the pure metal we're going to put. So when we're going to melt, I'm going to put on top of it the pure silver. So when the pure silver is going to start melting, everything is going to mix well together instead of adding it afterwards. Okay. And it helps for the oxidation as well. I have pure and let's say used metal, so already casted metal, and I always start with my clean mix. Once it's liquid, I'm going to start adding my sterling. So I start melting all this together. I'm going to have to heat up my ingot maker. I don't know what you call that in English, but I'm going to wait for my metal to be a bit more liquid first. Like that doesn't going to have too much change of temperature.
Yeah.
Between when I melt the metal and when it's ready to be poured. You always aim for the bottom of the crucible while you melt, to be sure that first of all everything is going to be liquid, and to suck in the not melted metal into the liquid metal. I'm going to use a quartz steering rod that I'm going to heat up a bit before using it into the metal, for the metal to not stick to it. And I'm just going to check if I have no more like solid piece into my mix. Once that is verified, I'm going to start adding the used metal to mix it in. When I'm almost liquid, I'm going to take some borax. I'm going to put it on my metal, and it's going to help me clean all the oxides and all the impurity into the metal. Now that I'm liquid, I'm going to start heating up my ingot maker. It's very important to heat up your ingot base, or when the hot metal is going to be in contact with the cold metal, it's going to splash. It can be very dangerous. So you have to be aware of what you're doing. I'm putting just a bit of wax for the metal to not stick, if I can. The last bit of borax. Okay, so ready to melt, to pour. So I go on top. And once I start, I don't stop. That's it. That's it.
Awesome, thank you.
Okay. And this going to the acid to be cleaned. We're gonna have to leave it for a bit in it for the acid to really work on it.
Is using a crock pot like a little hack?
Yeah, the crock pot is the best hack in our job. We used to use pots and little like heaters, it was a mess all the time. It's still a mess, but you can find this for like 15 to 20 bucks on Marketplace. So yeah. That's our thing. We change it every 4 or 5 months. It's easier than using a pan sure. and all the things. You see, we have a lot of copper oxides on it. I'm just going to go break them a bit, and I'm going to put it back into the acid. It's going to help the process. So as we've seen earlier, we've done ingots. I like to, mostly for sterling silver, I like to do my ingots first instead of using only the alloy and the pure metal. It helps mixing everything together. Then we usually laminate it a little bit just to put all the atoms together and cut it into pieces. And that's what we're going to use to cast into the machine.
Okay.
So...
Okay, yeah. So Lauriane was explaining earlier because basically you're talking about you're creating your own alloy mixture.
Exactly.
Yeah, because people don't know this. People think that like 10, 14, 18, 22 karat is all the same, but it's not. Every single person, like jeweler, for example, will create a lot of times their own mixture with their own alloys.
Exactly.
And that's, so you're doing your own.
And every color, and even for some colors, like for the white gold, we have two. We have the extra white and we have the regular white.
Yeah.
So we picked our alloy very precisely. We want something that have a very good fluidity while it casts, and we want obviously a nice color and a nice quality of metal.
Color is super important. Like you get like 14, 18 karats. Sometimes the mixtures are so pale. Like I don't. Yeah, you can see it. But you've also created your own mixture of silver that doesn't oxidize.
Exactly. It's a non-tarnish silver. It oxidizes, but it's 25 times less quickly than a regular silver, which is a huge difference.
Yeah.
And it has an amazing shine when polished. And it has that little... whitish, a bit more whitish than the silver can be a bit more
Yeah, we'll
grayish.
show you a little B shot here because it is a nice silver. So if ever you guys are some jewelers looking for some new casting house and you work with silver, this is a good option.
So we're gonna have the 3 ovens. Wait, we're gonna take them out.
Yeah.
We're gonna have 4 ovens. That's the main one where we put all the cylinder for the gold and the silver ones. This one is the one that I'm gonna use for platinum. So platinum cylinders have to rise at a much higher temperature until 900 degrees Celsius before being casted. And those two are when we have resin. The cycle of burnout for resin is different than the regular wax one. So we go through this one. And the little one is just when I want to reach a temperature different for a certain cylinder that I'm going to pull out from another oven, put it in to reach the exact temperature that I want.
Very cool.
From that step, we're gonna see it. We're gonna do it physically after that. From that step, we pull out the cylinder from the machine. Previously, we've put the metal into the crucible inside the machine.
Yeah.
So we have the crucible. We put the metal in. We close it. We start heating everything up. When you reach the right temperature, the bottom door is gonna release. It's gonna open. We're gonna put the cylinder, put it back in, and then go to the process, tell him exactly what I want as a parameters, and then he's gonna cast. This one is it's a more let's say classic way of casting. So this is differential. So you have 2 different pressure on top and in the bottom that helps the metal to push in and to be the density of the metal is very good with this if the parameters are well made. This one is for platinum that I use. It's centrifugal with a fully controlled environment, argon, vacuumed. Everything is under a controlled environment. Can reach to 2000 degrees Celsius, which is very high, but it's what I need for platinum.
Yeah.
And then that's where we do the platinum cast.
Yeah, so it's very technical. You see, he has them for every single type of metal, every situation. So it's pretty cool.
Just gonna open that bottle here. So that's the argon that just opened, and it's so you have an argon line for the environment, and we have water to cool down the machine while it's working.
Okay.
Yeah, that little noise, it's the heating starting.
Okay.
We're going to be able to, at one point you're going to be able to look, it's not very, very clean because it's with all the smokes and all it burns a bit, but you're going to be able to see at least a little bit.
So how long does this process take from start to finish?
While the metal is in the machine, it's going to take about 6-7 minutes top.
Wow, very nice.
The whole process, the time we melt. The first one is a bit longer because it starts from 0, so it has to reach the temperature. But after when I do other ones, the environment is already a bit hot, so it goes much quicker.
Very impressive. Okay, I didn't realize.
Yeah. So yeah, you can see it's going to start reaching temperature here on the screen, and once it's going to be 100 degrees before the reaching temperature, it's going to release the bottom part to be able to insert the cylinder. And yeah, we're going to have to wait for it to melt first. So this you can come see if you want. Here I'm going to go and I'm going to call the cylinder that I want. So I call it. It's going to start turning inside. It's turning tables inside. And once it's reached, I just have a sneak peek into the door to see if it's the right cylinder that I'm looking at. And it is. And we're gonna have a huge cylinder. So the second part, we're gonna do the ingot, prepare the metal. But the cylinder itself, it's a 5-inch on like 7-inch. So it's a huge cylinder.
Okay. Yeah. How long have you been doing this?
Jewelry?
Yeah.
Jewelry. I'm born in the industry. I've done the same school as my mom, the jewelry school du Louvre in Paris.
Wow. Okay.
And my dad is a diamond reseller till today in Paris.
Yeah.
So yeah, I've been raised in it. Since I'm 5 years old, I'm in a workshop, looking at people doing jewelry, and I started to do pocket money, like lunch money. I was polishing when I was around 11, 12 years old.
Very good.
Yeah, that's
Love
it.
that.
You're gonna see the metal. You see the liquid part starting, and then everything is gonna get sucked in it. It's a pretty good part of it. When you're a jeweler for that long, you're usually very hypnotized, fascinated by fire, metal, liquid metal. So yeah, first thing, I open my door. There's a raising bottom to receive the cylinder. And this. Start again. Then in the process, it vacuums, takes off all the air, replace it with argon. Every metal, every carat, every color has a different quenching time. So we have to be very precise with this to have the best quality of casting.
Because I think if you don't quench it quick enough, it'll crystallize, right? It'll change the
Depends
metal.
on the metal.
Okay, depends on the metal.
Mostly the most picky one is the pingo. Pingo is very picky. You don't have much time to quench it because there's a tendency to have a lot of retraction, so you have to quench it very quickly.
Okay.
For the rest, this one in particular, it's about 20 minutes before quenching. It's sterling silver.
Okay.
So we open it. And we start the timer.
Once the pieces are printed, we then assemble it on a casting tree, as you can see here. We can have up to 50 to 100 pieces depending on the size of the tree.
What's going on? Yeah. So silver in particular, the after casting is very black because of the copper oxidation. But after cleaning and under water pressure and the pickling salt, it's going to be a bright white. You can take off the noise from the video. It's awful. I can't hear it anymore, but listen. So we use water pressure. It's good. So yeah, those ones are bracelets, so it's one of a kind. Every bracelet is unique. So it's no place for error when we do those.
Yeah.
Because the jeweler spend a lot of time building them. So we have to be very precise and to be sure to not miss anything.
Those were made with wax
Carving.
carving that he did by hand.
By
right?
hand on the bench.
So it wasn't 3D design or.
It's either no 3D design, no mold. So if
Make a
meat,
mistake.
the guy is gonna have to redo it from scratch.
Done.
Here I can show you a little example of what I was saying a bit earlier. So this is 18 karat from wax, so you can see the surface and the quality of the surface of the band. This one is 14 karat from resin, so all the support that you have in the resin printing is gonna appear in the cast. That's where I was saying it's a bit less precise, but still, once cleaning is done, it's still very good quality.
Yeah, it just takes longer for the jeweler to refine
Exactly.
that afterwards, so it's
To
maybe not
clean it.
ideal if you're doing like heavy production, but
Exactly.
yeah.
If it's a custom-made piece,
Yeah.
it won't make big difference because
Yeah.
you're gonna spend a lot of time anyway on it.
Yeah.
And one of the points of the process is that the jeweler has less job to do. The more you work on it, the more money you lose, and
Yeah.
the more metal you lose also. So the point of it is to have the less details on the top of it and less work to do. That's why we also sometimes we finish the jewelry on barat to make it cleaner too.
Yeah.
And to start back from, and you're totally right, and to start right from the beginning, that's also why we pick those machines. Machines we use we're the first one in North America to use them, and it's very precise. It's the last technology we can find on the market, so it helps us achieve the best quality as possible. I've been a jeweler for 18 years in Montreal, and I've been struggling a bit with casting and the cleaning part of it. So I understand what's the problem for jewelers, what they go through, and I'm trying to solve all those problems.
Yeah.
And platinum was a big one, and I think we found the solution.
Yeah, no, I can speak
So-
for that. Platinum is often like a lot of like holes, it needs to be fixed, cracking, big
It's
problems.
a difficult metal to
Yeah.
work with.
It is a difficult metal.
And it's one metal that we wanted to perfect the casting of here.
And there's multiple things. Everything is different. The investment is different. The cooking time is different. The temperature of melting. We will have to reach 2000 Celsius degree to be able to have a liquid state of the metal. And we want it or no, it was a big struggle for all the jewelers. And thankfully, everyone that worked with us with platinum been very satisfied so far. So we're pretty happy of what we achieved.
Good.
Yeah.
All right, guys, thanks so much for doing this with me. If ever you guys have any questions, do leave them down below because we're gonna try to, get back to them. Obviously, hit that subscribe, smash that like button because it helps these small videos a lot. And these are B2B jewelers. So if you are somebody in the jewelry industry and you're looking for a new higher quality casting house, where can they find you?
But you can find our email online.
We'll link it below.
And our Instagram as well. Then just send us the STL that you need to print, and we go through the whole process, printing, casting, and pre-cleaning for you.
Perfect. And if you guys, if you have let's say clients in the US, a lot of our clients are in the US, that's okay?
We ship all over Quebec already, and we're gonna get wider with Canada, and then for sure the States, it's for sure a possibility.
And if you want to check out our presence online, it's LB Font or LB Casting if you want to check it out.
Yeah, they just launched a new channel, so you guys can check out the behind the scenes because they're gonna be posting. So yeah, thank you guys so much.
Thank you.
Thank you for
Thank
coming.
you very much.